and welcome to part 2 of our lesson for geometric proof, lesson 2.6. We're going to be jumping right into where we left off. I will be going through some things that are a reminder of the first part of the lesson. Feel free to pause and write any of these down that you didn't get written down during the first video, but we will go through these rather quickly and then get straight to example 3, which is really the only thing left that we haven't covered from this lesson. So we will be writing geometric proofs again. Remember, when writing a proof, it's important to justify each logical step with a reason. You can use symbols and abbreviations, but they must be clear enough so that anyone who reads your proof will understand them. And this is our reminder of the proof process. You'll start with a hypothesis, that's the given information. We will make statements using definitions, postulates, properties, and theorems as our reasons to arrive at the final conclusion. So just a quick reminder of some of the definitions you were given. I'll quickly scroll through these. If you need to copy any of these down, go ahead and pause the video so you can do so. Here are two of our theorems. Go back to those, give you a moment or two more. Here are another two theorems. Some more information that needs to be placed in your notes if you haven't done so already. And remember to plan out your proof, plan out your logic in some way. A lot of these first proofs we'll be doing will have that done for you. So once again, here's your helpful hint. If a diagram for a proof is not provided, make sure you draw your own and mark the given information on it. But do not mark the information in the prove statement. You can make a note of what you're supposed to prove, but you cannot mark it as true in the diagram yet. So here's your proof process again. Write the conjecture to be proven, draw a diagram to represent the hypothesis, state the given information and mark it on the diagram, and then state the conclusion in terms of the diagram. That just means look at the diagram, understand what about that diagram you are supposed to prove, and then lastly, plan out your argument and prove the conjecture. So let's take a look at example 3. As I was preparing this video, I did notice there's a typo in your notes. In example 3a, this statement right here, I will highlight that for you. That statement is incorrect. It should be replaced with angle 1 is congruent to angle 3. So please make a note of that. This should say angle 1 is congruent to angle 3. Angle 1 is congruent to angle 3. We'll be using that in our proof. So we are given that angle 1 and angle 2 are supplementary. Notice they're not adjacent, they don't have to be, but you're told angle 1 and 2 are supplementary. There's no way to really mark that on the diagram. But we are told that angle 1 and angle 3, again, are congruent. We can mark that. Sorry, wrong symbol. We can mark that in our diagram like this. Angle 1 is congruent to angle 3. And we are supposed to prove that 3 and 2 are also supplementary. So here's what we're going to do. We're going to use the definitions of supplementary and congruent angles and substitution to show that the measure of angle 3 plus the measure of angle 2 equals 180. That statement covers a lot. In fact, it covers the first 4 steps of the proof. So we can conclude by definition of supplementary angles, 3 and 2 are supplementary, and that's the last step. So let's clarify here. We're going to use the definitions of supplementary angles. Well, we're starting with the given information. Okay, we know angle 1 and angle 2 are supplementary, and angle 1 is congruent to angle 3. Let's put all the given in one statement this time. And we know that is given to us. Then it says use the definition of supplementary before we go on to anything else. So I'm going to define what that tells us. Since they are supplementary, I know their measures add up to 180. Once again, that's the definition of supplementary angles. Because their measures add up to 180, and because angle 1 is congruent to angle 3, I could replace angle 1 with angle 3. But before I do that, I need to talk about the measures of angle 1 and angle 3 by definition of congruent angles. You have to change this statement to where it talks about the measures, so we have values to substitute. You can't substitute figures, you can substitute values. So since the measure of angle 1 equals the measure of angle 3, I can substitute the measure of angle 3 in place of the measure of angle 1. That reason is substitution. So, since this is true, by definition, 3 and 2 are supplementary. And we have proven what we set out to prove. Let's try example 3b. Why don't you take a minute or two, look this over, read the plan, and see if you can start working towards this proof. Alright, hopefully you've had a chance to at least begin. We are given two pieces of information. 1 and 2 are complementary angles, and 2 and 3 are complementary angles. Very similar to what we were working with previously. It's just instead of proving this part, we are given that, and we're going to prove that 1 and 3 are congruent now. And we're going to do that this way. The measures of complementary angles add up to 90 degrees by definition. Use substitution to show that the sums of both pairs are equal. Then we're going to use the subtraction property and the definition of congruent angles to conclude that angle 1 is congruent to angle 3. So this is the plan for our proof. So the first step in our proof is to talk about the given information after looking at the diagram. We know that 1 and 2 are complementary and angle 2 and angle 3 are complementary. That's given to us. This says that the measures of complementary angles add up to 90 degrees by definition. So the next step is to explain that. We can put both of these in the same step. Now, it would be possible to write these separately, and you can make your proof longer that way, but I'm combining steps here. And the reason for that is the definition of supplementary angles. Sorry, that should say complementary. Let's fix that. Easy fix. Now, since 1 plus 2 equals 90 and 2 plus 3 equals 90, we can substitute 1 and 2 for the 90 in this other equation, or think of it as substituting 2 and 3 and this is the 90 for this equation. So the measure of angle 1 plus the measure of angle 2 would have to be the same as measure of angle 2 plus measure of angle 3, since they're both 90. Substitution allows us to say that. You could also use the transitive property of equality. Since these are equal, and remember, these represent values, measure of angle 2 would be the same on either side, we can go ahead and state that as a reminder in the proof. This is one of those steps that wouldn't have to be written in, but it's a good reminder, so we're putting it in this early proof. Measure of angle 2 equals itself by the reflexive property. Since 2 is equal to itself, we can subtract that value from both sides and leave the equation balanced. If I do subtract measure of angle 2 from both sides, all you're left with is the measure of angle 1 equals the measure of angle 3. Once again, we could subtract that from both sides, subtraction property of equality. So if the measure of angle 1 equals the measure of angle 3, angle 1 and 3 are congruent by definition. So we've just proven that angle 1 is in fact congruent to angle 3. Well, I hope this helps understand proofs a little bit better. We will be spending more time in class working on proofs. As always, the best way to practice proofs is by doing proofs. The way to get better is by doing more and more practice. And another thing that's going to be very helpful for you is to make sure that your vocab notebook and your note packet are caught up with all vocabulary terms. That includes definitions, theorems, postulates, and properties. So please, once again, make sure you're doing the adequate reading and vocab work to better understand these reasons and what they tell us.